you to just clap one time. Go. Thank you.
Go team.
And I need you. Thank you. And you can remove your mask and you're just talking with Emma.
I look at Emma?
Yes,
Yeah.
please.
Okay.
And then also, would you mind, this isn't a formal interview question, but would you mind telling me a little bit more about that straw thing?
Sure, I brought this stuff, yeah.
Okay.
So essentially what I do with a group is I'll pass out little Dixie cups, or little bathroom cups, and straws, and I give everybody water, and they take a sip of water. I say, oh, that's easy. And it mimics how trees move fluid through their cells. So you got xylem and phloem, and they move up and down.
Okay.
I don't have to get too scientific, but so then you sucking the water up mimics how water and nutrients move throughout the tree. The adelgid is an aphid-like insect. It pierces the branches and sucks sap out. So I give everybody push pins, and they pierce the straw. A lot of holes in there. And I say, then take a sip of water, and it's more difficult to sip the water up because there's a lot of holes in the straw. And so that mimics how these trees have a lot of holes in their branches, and they're not able to move nutrients and water around, and they slowly starve to death.
Okay. Gotcha. I love the analogy.
I picked that up from another ranger at another park.
What do you all think? I don't know if you heard what she just said. Think about getting that somehow on film, or maybe just talking about it.
Okay.
I don't know.
We can, whatever, yeah.
Okay.
I don't know if you want me to suck water through a straw and get the sound.
Because I didn't realize you were rolling at first, so some of my.
Yeah, she was just giving you information.
Okay.
Right, there could have been something.
All right.
We're still rolling.
Okay, I'll just ask you a question about that, and later on we might
Okay,
demonstrate that.
You have to
We don't
do
have
your
to do it.
name and spelling and
That's fine.
I'll get an audio.
Okay, sounds good. Okay, would you mind just saying your name and also spelling it?
sure. My name is Mary Griffin, M-A-R-Y-G-R-I-F-F-I-N.
Perfect. And then throughout this interview, if you could just kind of look at me.
Yep.
We're just having a conversation.
Sure.
And then when I ask you a question, if you wouldn't mind just kind of answering in a complete sentence,
Rephrasing the question in the
that would be perfect.
answer.
Um,
I'll try to do that.
And then,
Yeah.
might ask you to say my name is Mary Griffin. You might want to use that as your identifier.
Okay. I'll DM then.
Yeah, without spelling it.
Okay, sounds good. And then this is also for like a 6th grade science type audience. So I know you have a lot of like outdoor education experience talking to younger people or people
Sure.
that aren't as scientific. So if you kind of use those or keep that in the back of your mind.
Yeah,
when you're
absolutely.
talking as well, that would be awesome. Thank you.
Yeah.
So again, would you just kind of mind saying who you are and what your position is, what your relation to the park is?
Sure. My name is Mary Griffin, and I'm a park ranger with North Carolina State Parks.
And what is your relation to this park in particular?
So I've worked here at Hanging Rock State Park for about 7 years, and currently I work at South Mountain State Park.
And why did you decide to be a park ranger?
I decided to be a park ranger because I thought it'd be a fun job. And I was right. Every day is different. I come into work thinking I have a set amount of things I'm going to do, but something always comes up and changes. But every day is different, and I get to work outside. I get to work with the public and with other park rangers and other staff.
And why is this area so special?
Hanging Rock is special because this state park is the epitome of what a state park can be. It's got all kinds of recreational activities that you can do: hiking, mountain biking, horseback riding, camping, picnicking, swimming in the summertime, canoe rentals, there's a river, there's rock climbing. So it's a dynamic park. The folks who visit are great, and the folks who work here are awesome as well.
And, Mary, if I can make one suggestion.
Sure.
I know you're 15 feet from us, but the microphone's right on your clothing, so you don't have to raise your voice at all. Okay.
Okay.
In other words, you don't have to project because it's going to capture the sound.
So you want me to talk softer? Is that what you're saying?
Yeah, just talk the way you,
Conversation, yeah.
Just-
That's the great part.
the way you
Okay.
would if somebody were
Yeah,
3
if
feet
we're real
from
close.
you.
All right. I'm
hear
open
everything.
to direction, so you just tell me bluntly and I'll get it. All right.
And then how did your relationship with hemlock trees begin?
My relationship with the Hemlocks began as a ranger. Another ranger was working here, and he invited me out for hemlock treatments. and I had no idea what he was talking about. So I thought, well, I'll just tag along and see and help him out. And I thought it was really interesting. I thought we were doing a good service for the park and helping preserve these trees. And the more I learned about it, the more interested I got and just went deeper and deeper into it.
When you were here, would you mind telling me a bit about the kind of educational programs you did with the Hemlocks?
Sure. So as a park ranger, we offer a lot of different programs for the public and for school groups and different groups that come in and visit. And I started a program with the hemlock trees here, just talking about the natural history about the hemlocks and how they serve the environment around us. We do some activities and go for a hike and observe the hemlocks and how they look in the wild.
How could I, as a layperson, identify a hemlock tree?
So hemlocks are a conifer, so they have needles, and able to identify them, you need to get outside and look at trees. Now these needles are a little bit smaller than what you may be used to seeing on pine needles. They're much smaller. They have smaller cones. But to my eye, I've been out in the woods so much, they have a different shade of green. So I can look down a row of trees and just kind of pick them out. Or as I'm driving down the road, I can see the green. So it just takes a little bit of practice, getting out, getting your hands on some trees and looking at them.
Is there anything unique about maybe that you kind of touched on this a little bit, but about like what the actual branches look like compared to other trees or pine trees?
Let's see. The hemlock branches are a little bit dainty. They kind of hang out. They're very pretty. They're aesthetically pleasing. So as you're walking through the forest, they do look a little bit different than pine trees. The hemlock trees keep their branches from the bottom all the way up to the top, so that's another way you can identify them. Most pine trees kind of drop their limbs as they get taller, but the hemlocks will maintain their branching from the bottom up.
What is happening with the hemlocks in this area?
So on the east coast of the United States, there's an insect. It's an aphid-like insect called the hemlock woolly adelgid, and currently it's pretty much in the entire range of the eastern hemlock, so up and down the east coast of North America, and it's slowly killing off these trees. So it's a hemlock woolly adelgid. They pierce the branch with their mouth parts, their sharp mouth parts, and they feed on the sap of the hemlock. So this interrupts the nutrient flow within the tree, and these trees are slowly dying. It may take several years, but they also weaken the tree, and that allows for other insects to come in or other disease to come in and kind of wipe out the tree as well.
How does climate change impact this process?
Sure, that's a good question. So with climate change is changing the seasons a bit, and so the aphids tend to go dormant in very cold weather or very hot weather. So when we don't have the usual winters or the usual summers, then these insects are going to be active year-round, feeding and reproducing, and so that's just going to create a larger problem for the hemlocks in this area.
And why are these trees especially vulnerable?
The hemlocks in North Carolina and Hanging Rock in particular are vulnerable because this insect, the adelgid, is not native. So this is an insect from southern Japan that got imported, probably on some nursery material, and it slowly made its way to North Carolina in the 90s. So there's no natural predator for it here. So in its natural habitat, the adelgid probably has some predators that feed on it, keep it in check. The trees probably have a natural immunity to it. And so here, there's nothing to keep it in check. So it just goes wild and just spreads and kills off the hemlocks.
Is it, are these insects only specific to hemlocks?
Yes, the hemlock woolly adelgid is specific only to the Carolina hemlock and the eastern hemlock here in North Carolina. You won't find them really on any other trees feeding. You might find them on there, but they're not going to be feeding on it as they do on the hemlock.
And do you know how big the hemlock woolly adelgid problem is in this park?
So the hemlock woolly adelgid is a problem in Hanging Rock. It's everywhere. But the park staff has done a great job of getting out and treating those trees that are along the river corridors or the creek corridors, and the high visibility areas around our waterfalls, on our trails. Hanging Rock is 8,000 acres with a limited staff and limited resources. So we can't treat every tree, but what we hope to do is treat the ones that we can see from the roads and from the trails, the ones that are protecting the watersheds, and hopefully introduce some beneficial insects that can also create an integrated pest management and try to boost the trees that we can and help spread the immunity throughout the forest.
Cool. So do you know exactly how much the adelgid has infected out of the proportionally in the park, or you just know that it's a big problem?
The adelgid in Hanging Rock is everywhere. You could go to any stand of trees and find it. The trees that we have treated, you'll be harder to find adelgid. But we've been treating the trees in Hanging Rock since 2009. So most every tree that we want to treat has been treated at least once. And so that's great news. That's good news. It's been a lot of hard work from the folks here in the park. And so you won't see a lot of adelgid on those trees, but it's cyclical. So after a few years, we'll have to go back and retreat, and you'll see the adelgid is back.
And how many? Do you know the scale of hemlocks to other trees in Hanging Rock?
Oh, that's a good question. So the Carolina hemlock and the eastern hemlock kind of have overlapping habitats. The Carolina hemlock tends to like rocky outcrops, and the eastern hemlock tends to be along creeks and rivers and kind of drainages like that. So there are places where they'll overlap some. So you don't see hemlocks everywhere in the park, but you'll see them up on the ridge tops. If you go up to Hanging Rock at the overlook, you'll see them there. If you go up to Moore's Wall, you'll see them up there. If you come down by the river, if you go along Cascade Creek, by any of the waterfalls, you'll see them there. So in those areas, they're more densely populated in the forest, but if you go to other areas, you won't see any at all. So it kind of depends on where you are.
Okay. And what is the treatment that park rangers have used?
So there's different treatments that we use here at Hanging Rock State Park. We have water-soluble pellets that we insert into the ground around the tree trunk. So we'll measure the tree we'll measure the diameter of the tree at breast height, and then depending on how big that tree is, it gets so much treatment. So we'll inject these pellets into the ground when it rains, or the soil moisture will help dissolve them, and the trees will take that insecticide up through the roots. We have a soil drenching method where we dissolve packets of insecticide within water, and then we'll pour it around the tree roots. That's much quicker to take up. And then there's also some beneficial insects that we release, some beetles that are native to Japan and Asia that eat the adelgid, and so we come out and release those as well.
I knew we'd have an airplane. Right directly overhead.
Yeah, we don't get too many. Somebody's out for a joyride.
Ladies and gentlemen, the air battle of Britain being recreated at Hanging Rock. Thank you.
Your headphones.
A muffler. I hate to stop rolling because we got to restart everything.
With this, you're not stopping.
No.
Yeah.
If we do, we got to push it.
Yeah.
So I'm trying to. He's almost. He's hanging on.
he's looping back around here.
He's coming back around. Okay, let's do it.
Okay, out of your headphones.
Yeah.
Cool.
Yeah.
Would you mind actually naming what the specific chemicals or treatment that you use are?
Sure. So the chemicals we use on the trees, on the hemlock trees, is called imidacloprid, and it's essentially like flea and tick medicine you might give to your dog. So it's systemic, so the tree takes it up through the roots and it goes out throughout the tree, the way the tree moves water and nutrients throughout the tree. And so when the adelgid injects its mouth part into the branch, it sucks up some of that insecticide and then gets killed off, similar to how a flea or tick would with a dog. So that comes in water-soluble packets that we can pour around. It also comes in pellets that we inject into the ground. And then these beetles, they have very long scientific names, but sassy beetles or Larry beetles are released in areas that haven't been treated recently, so that there are adelgid that they can feed on. And they only feed on adelgid. So when the adelgid runs out, the beetles are gone. They don't have a food source.
So do you see any issues with the beetles being released?
I don't have any issues with the beetles being released. They're reared in a lab in Raleigh with the North Carolina Department of Agriculture and Consumer Science. So they're reared for years. They go through testing. This is a controlled population. You know, this is a known species that only feeds on the adelgid, so that we're not just releasing and hoping that these beetles work. We know that it's going to work and there's not going to be a beetle infestation.
And then would you mind talking about sort of how effective the treatment is and how long it lasts?
Mm-hmm. Sure. So we found that the chemical treatment using the imidacloprid is very effective. The trees take it up, and usually about 3 years, they're good to go. We try to stretch it out just because of resources are limited and staff time is limited. So usually we can stretch it out to 5 to 7 years. We want to kind of monitor the trees, and once we start seeing the adelgids showing back up, we want to treat again before it becomes a reinfestation. Once a tree loses about 50% of its needles, it's probably not going to make it. So we don't usually treat those just to save those resources. So we try to monitor every couple of years, keep an eye on the trees, and the treatment, we can make it last about 5 to 7 years.
And then is there enough park staff and resources to be able to retreat all the trees in that amount of time?
Mm-hmm. So within that 5 to 7 year span, we can usually get around the park and treat. So we're treating every year. And there's other outside groups that help us. There's the Hemlock Restoration Initiative that comes in and helps us. They have a crew that's great, and that's pretty much all they do. So they're real professionals at it. They're moving through the forest, and we can treat with them. We can treat over 1,000 trees a day with them. So they're really moving. We can call in other agencies to help us, and we call in some volunteers and try to gather all the staff we can from the park.
Awesome. Why are hemlocks important?
Hemlocks are important because they have so many functions in our forests. So I spoke a little bit about how they have limbs from the bottom up. So they hang on to their limbs. So they're a ladder species. So that allows animals that don't have wings to get up into the forest canopy. It's a great habitat for birds, lizards, chipmunks, squirrels, whatever needs to hide out. And these limbs also shade the forest floor or the creek beds they're growing next to. So when they're shading the forest floor, it keeps the soil moisture constant. You don't get fluctuations in soil moisture. When it's shading water, it keeps the water cooler, and cooler water holds more oxygen and drives algae levels down. So that's more oxygen that's available for fish like trout, salamanders, other amphibians, other insects that live in the creeks. So there's more biodiversity than does that. So, and they're pretty to look at.
And I guess similar question, but what is the consequence of hemlocks dying out in this park if we weren't treating?
So if we're not treating these trees and they're dying out, we're going to have a lot of dead trees in our forest. So, you know, first thing that pops to mind is wildfires. So you got more fuels on the ground or standing up. You're going to see the soil moisture fluctuate. It'll get dried out. You'll see the creek beds get a little warmer. You might start seeing some species migrating out of the area. So it's going to have effects far-reaching.
Would you mind talking a little bit or elaborating a little bit more on the trout specifically and kind of what's happening in the water, like with hemlock shading the water and
Sure.
the oxygen content?
So trout really like cold water. They're a cold water species. So once the water temperature reaches 76 degrees or so, they're going to start looking for colder water. So these hemlocks are shading the creeks around here in the river and keeps that water temperature low. So as the water temperature stays low, the trout are able to lay their eggs. The eggs like to be oxygenated. So this cold water is holding more oxygen. The eggs are staying viable, and they're just going to be able to prolong their life cycle there.
Cool. If you could boil down the whole complex issue of the hemlocks in this park to like one sentence, what is the most important part of this science lesson to you?
Oh man. Oh man. So in dealing with hemlocks, you know, I've talked to some folks who think that hemlocks are going the way of the chestnut blight, or the chestnut trees, the American chestnut, and that when the blight came in, it wiped out a bunch of trees. I'm a little more hopeful than that. And we got a lot of folks on the ground that care about these trees, that care about our state parks and our public lands. So, you know, I have a lot of hope that the hemlock's gonna make it through this adelgid infestation right now and come out on the other end.
Awesome. And why do you care about the hemlocks?
I'm a big tree nerd. No. I care about the hemlocks because, you know, they're a beautiful tree, and we have so many here in Hanging Rock, and I think it just adds to the forest beauty. And they have so many uses here in the forest, and that helps the environment in terms of habitat, in terms of keeping the ground cool, in terms of keeping water cool and oxygenated. So it's an important species. They're slow growing, and they just get more than 100 feet in the air. They're just magnificent trees.
Cool. Is there any other things that I haven't explicitly asked that you think are important pieces of information to add? Or takeaways, or?
Yeah. Keep supporting your state parks. No, I don't know.
Is there anything you all
I'm
have?
just wondering, do humans have any role other than contributing to climate change that has led to this spread of the woolly adult?
Okay. Did you hear that question?
Mhm.
Or? Okay.
Yeah. So probably humans are responsible for the introduction of the woolly adelgid to the United States. Probably in tainted nursery material, and then that's probably how it spreads. It may spread on the feet of birds, but most likely it's tainted nursery material and then just kind of gradually moved from there. So in terms of human impact on global climate change, definitely the tainted nursery material, and also just deforestation with development and changing the landscape as we know it.
How does deforestation specifically impact the spread of the adelgid? Or is it?
So the development is more of just taking away habitat so that we don't have healthy stands of trees. It's not really about spreading the adelgid. No.
Cool.
Anything you want to ask that we didn't cover? I think it's pretty comprehensive.
Yeah, and all the questions that we have are pretty much checked off. So, I don't have anything to add.
Thank you so much.
Thank you.
Yeah. Did y'all want to look at a tree, or y'all going to look at trees later?
Yes.
Okay.
We'll have-
Please. You rolling? Emma?
Good. Yep.
Okay, clap, please.
Oh.
All right, and anytime.
Okay, so what do you have here? Can you demonstrate?
Sure. So this demonstration will kind of mimic how a tree moves water and nutrients throughout its system.
Let's start again. You already have it in your hand. Let's just start that. Just,
Okay.
yeah, go ahead.
Okay.
Okay, so can you just demonstrate or show how the straw can compare to the tree?
Sure. So this is going to demonstrate, this cup of water in this straw is going to demonstrate how water moves through a tree. So if I take a sip of water, it kind of mimics how fluid or water, nutrients in a tree move up and down. So trees have xylem and phloem. That's how they move nutrients throughout their system. And they make food. That's how they move it throughout the system. So in a healthy tree, water, nutrients pass freely.
Start again. Emma, you're in the shot. So, let's just start again. And I'm going to go a little bit tighter, Emma,
Okay.
because you're just seeing right there. All right, let's start again. Go ahead.
Okay, so the straw, how does that compare to what a tree does with water?
So this cup of water and this straw kind of mimic how a tree moves water and nutrients throughout its system. So there's xylem and phloem in a tree. They move water up and down, nutrients up and down. So when I sip through the straw, that's like a healthy tree being able to move the nutrients and water. So when a adelgid comes along, they have very sharp mouth parts. They come through and they pierce the branch and they suck the sap from the tree. So that mimics, so this push pin kind of mimics that motion that the adelgid is doing. So you can have hundreds and thousands of adelgid feeding on the same tree. And so it kind of, this push pin is representing the adelgids as they feed on the tree. And they put tiny, tiny holes in the branch all up and down of the tree. So when the tree goes to do its normal functions of moving water and nutrients around, they find that it's a little bit more difficult. And you try to take a sip, a lot of air moves around, very little water when I just sipped on the water. So that kind of mimics how the adelgid physically affect the hemlock trees. These trees are unable to move the nutrients and water around. Their whole system is disrupted, and the hemlock trees slowly die. They're slowly starving off, and it weakens the tree and it opens up the hemlock trees to other insects and to other disease that can come in and kill off the tree.
Okay, cut. At this point,
Okay.
you don't even have to have the pin there. Good.
How close can I get?
You can get close. I'm tight in on the cup.
Okay.
Okay, what was your next thing, Mary?
So I just.
You're going to sip it? Yeah.
Yeah.
So let me
So
get that. Just get
So
some
this
off.
is a tree, and it mimics a tree system. So I'll sip some water. So the healthy tree water is able to move up throughout the cells.
Do that again. Go. Didn't you say I'm going to sip some water? Did you say that? Before I sipped it? No?
Yeah. So I'm gonna sip this water. I'm gonna need some more water. Georgia, can you throw me that bottle?
Sure.
What do you want from me?
You're doing great. This is how you torture actors on the commercial.
Yeah.
And then say, that water.
Oh, it's so good. I'm gonna get a big cup. I'm gonna need a bathroom break after this.
It'll make her laugh or that pin's gonna get.
I tell you what, it looks kind of weird to have her half face in the cup. I'm just going to shoot.
Okay.
Tight of everything. Or her taking a sip, it doesn't make any sense. That's great.
You may have snorted up my nose.
Yeah,
Would that be more interesting for the
Yeah.
viewers?
All right, looking right at
So
Georgia.
ask the prompt again, Georgia.
Here we go.
when she's ready.
Okay, so how can this system represent a tree?
So this cup of water and the straw represents a healthy tree. So when I take a sip of the water, that's how water freely moves within a tree. The tree roots are able to take it up through the cells. So when the adelgid attacks the tree, the mouth parts pierce the branches, like so, like a push pin.
All right, stop. You're doing. Take the pin away and just start with that section again. And
Okay.
go.
So when the mouth parts of the adelgid pierce the straw like a push pin, the mouth parts of the adelgid pierce the branch like a push pin pierces the straw. And the adelgids, there could be hundreds and thousands of adelgid on the branches, and they just repeatedly pierce the branch and feed on the sap. So you have hundreds and thousands of little tiny holes within the branches on a hemlock tree. And these holes, when the tree goes to move nutrients or water, that system is disrupted. I'm going to take a sip of the water and mimic.
Okay. Hang on 1 second. Go.
And so I was able to get very little water up because of these holes. And that is how And that's how the hemlock tree slowly starves to death because they're not able to move the water or nutrients around the system, and it slowly starves. It weakens the tree and opens it up to other insects that can come in and kill off the tree or other disease.
Good. Just hold the cup exactly like you're doing it. It's perfect. And then I know you got some good stuff there too. And maybe rotate the straw a little bit, see if I can see the holes better. There you go. Okay. We're good. Cut. Are you good, Emma?
I think so. Yeah.
Do a little clap for us, please.
Just clapping.
Good. Anytime, George.
All right. So, how could you tell if this tree needed to be treated or not?
So this hemlock tree is a fairly large tree. It's a medium-sized tree. So if you look at it, you don't really see any branches down below. As they mature, get pretty old, they start losing some of the branches. But if you look up top of this tree, you can see the green needles, and it looks pretty healthy up there. So this tree is fairly healthy. It's been treated before, several years ago, but we'll treat it again.
Okay. And you said it had been treated before. When was it last treated?
It was last treated in 2017. So it's still looking good, but just to keep the tree healthy, we're going to treat it this year.
Okay.
I'm sorry, you're in the shot.
Sorry.
Right, you're good. Let me go a bit tighter. Let's do it again, Mary.
Yes.
Unfortunately, point up. Don't look up.
Point up, don't look.
Because
Okay.
of the audio, it goes away.
Okay.
Yeah.
Okay.
Let's just do it
start
again.
Got it.
over.
Are you good, Emma?
Give me 2 seconds.
You just say you're good or whatever. You can yell at us.
Okay, I'm good.
Okay. So, how would you be able to tell if this tree was healthy or if it needed more treatment?
So walking up to this tree and we're looking at it, we don't see many branches down below. So we'd look up at the top of the crown, and if we look up there, we can see some green needles, and it's looking pretty good. So this tree was treated back in 2017, according to our records. So we're going to treat it again and make sure that it's protected from the hemlock woolly adelgid.
Is there anything special about this tree since it's so big? Or anything that's different in the treatment?
So we'll measure the DBH, that's the diameter at breast height, and the larger trees get more chemical since the chemical has to be dispersed in a larger tree. So the bigger trees get more chemicals and the smaller trees get less.
Is there what's kind of the sequence of how you would go about starting to treat a tree like this?
So in order to treat a tree, the first thing is we look at the tree and make sure it's healthy enough that's going to withstand the treatment, and if it has adelgid on it, that can withstand that. And then we'll measure the DBH, so diameter at breast height. Then we'll clear the leaf litter from around the base of the tree so that the soil is bare mineral soil. And then we'll measure out the correct amount of imidacloprid, or the chemical, and then we'll pour it around the base of the tree and then cover it back up with the leaf litter. The chemical is sensitive to sunlight, so we want to cover it back up. We don't want it to break down by the sunlight before the tree can take it up in its roots.
And is there anything special you have to do after treatment, like monitor the tree just to make sure it's doing okay? What happens after?
So after the treatment, we wish the tree good luck, and then we'll come back in the next year or two and kind of check on it.
I think that's all
Cut.
Yes.
Walk with all this stuff. So,
Boys, anyway.
or walk up and we'll measure the tree.
Yeah, I'll have you walk past my camera first, and then we'll just pause, and then I'll cut, pause.
Okay.
So right now, just walk past.
Okay. From here?
Yeah, that's perfect. Awesome.
Anytime.
Okay. Here I come.
I'm good.
Okay,
All right.
close-ups of the chemicals and stuff?
Yeah.
I'm gonna shake it.
I might have you shake it like a little bit more.
Yeah, it needs to be shaken a lot. There we go. Okay, then I'll measure the tree. This is 22 and a half. Makes 23.
So would you hold it there? So Emma
Yep.
can come around. You had your left hand over your right hand, by the way, when you measured it.
Yeah,
Your left hand was over your right.
my left hand was,
Just at your wrists. Yeah.
my right hand was underneath like that. I think that's what it looked like.
That looks fine. Am I too much in your way if I stand right here for you to do that again? This one, okay. Okay. Let's try that again.
Okay. Ready?
Yeah. And one more time.
Is that the no-K spot? Am I hitting the wrong
No,
spot?
no, that's perfect.
Okay. Ooh.
Okay.
Is that gonna work?
Yep.
I'm gonna move toward the side now. Okay. I might move to the other side a little bit too. Okay.
All right.
So now,
All right.
okay, so I'm gonna pour pesticide into the measuring cup.
Oh wait, this is low.
Well, I'll probably hopefully not throw it at anybody, but I'll pour it at eye level. Does that make sense?
Yes. I will use this.
Sorry.
No, it's okay. I just want to make sure I'm prepared.
Yeah.
So, and if you stay there, I can get you the wide shot.
Awesome. Thank
Stay
you.
on the cup.
So will you be lifting up to your actual eye level?
Yes.
Okay, perfect. I might just shoot right over it then, kind of looking at your eyes.
Okay. Whatever,
Hold it
whatever
like-
you want.
Okay, if you hold it like right kind of below,
You want to hold it
Your
in
nose.
front of my face?
or like kind of like you're looking at it. Oh wait, you need to measure it.
I got to see
Okay,
how
never
much.
mind then.
What?
I was envisioning like your eyes peeping over the top, but then you're not actually.
I don't want to.
realize you're
This
not
is
actually
poison.
measuring it. Okay, no, do whatever you need to do.
So what I envision doing is holding it up and then pouring.
Okay.
Do you want me to? You
No,
want?
that works too.
Okay. Work for you, Bob?
Okay, I'm good whenever you are.
Okay. You do that again.
I think I'm good. You have the whole thing wide?
Mhm.
Okay, perfect.
Okay.
Um,
So now I'm going to pour it on the ground.
okay.
Along.
Please. And anytime.
Okay. And you want to do a close up?
There you go.
Good?
Shoot away.
Did that work for you,
Yep,
Bob?
that works.
All right. And I can start wherever you want.
Okay. How about like here?
Okay. I try to avoid the rocks just because
Oh, gotcha.
they don't
Okay.
absorb through rocks.
Here?
Yeah.
Does that work?
Yeah. You ready? Oh, I'll wait for you. Oops.
Those stitches. Alright, so that's perfect.
Right there.
Yep, we're good.
You good? Is that good? You want some more?
So my question.
Yep.
Go. Good. We'll do close-ups.
Okay.
Okay. Alrighty.
And you can, hang on, you can start kicking.
All right. I'm going to cover this back up.
Okay, you got some close-ups. Keep on kicking, Donna. Yeah, let Emma tell you where she is.
This whole half, right?
Yep, that needs to be covered.
Just go for it.
So I'll
just
start
go for it.
at my end and walk towards
Okay,
you.
Sounds good.
Okay. I'm gonna come closer.
Alright.
And some more. Okay.
Alright.
There's a little bit right here. I don't know if you want to get that. This area. You ready?
Wait. Sorry. Oh,
No, you're
go
good.
for it. Okay, perfect.
Before we move from there,
So that was a hike to get to. But we treated those with Margot's crew. Yeah.
We have as many as we do here. We've got a pretty healthy population.
Mm-hmm. There's a lot. I mean, yeah, all along the rivers there. And there's just a small grove of Carolina up on this ridge top. So, yeah.
So how are you treating it?
Um,
Injection?
it's not. It's just soil drenching. So in these envelopes are water soluble material. So you get down to mineral soil around the tree, and then you pour it around the base of the tree and cover it back up. So the chemical is sensitive to light, so it breaks down with sunlight. So you want to cover it back up with the leaf litter, shotgun shells. But you can put like two to four of those in your belt and walk around with them. But yeah, Margot has big gallon jugs that they walk around and they refill. So yeah, it doesn't go very far. But now that you can get the gator through here, before we didn't have this trail, so
That's why I didn't remember coming up here.
we hoofed it up from the bottom.
Yeah, I remember that.
Yeah. Yeah, I mean, I guess you could try to use a measuring cup. And then once we treat it,
I've
but
seen the girdling some trees up in the camp.
yeah. So yeah, just spray paint so that when we're working in an area, we know that we've treated that one today. Yeah.
Okay, so can you talk about any trees around you and how you tell if they're a good candidate for treatment or not?
So when we're looking at trees as candidates for treatment, we'll take a look at the tree as entirety. So this tree, you can see it's missing a bunch of foliage. It's less than 50% covered in foliage. So this is not a good candidate for treatment. It's too far gone, and so we'll leave that one as is. And then looking at this tree here, this tree has more than 50% foliage. It's a little bit small, but it's a good candidate, and we'll still treat this one and hope that one will survive.
Okay. Emma? And slide, please. Anytime.
Okay, so can you talk a little bit about how you would look at a tree and judge if it's a good candidate for treatment or not?
So when we're in the forest treating trees, we like to take a whole look at the tree that we're approaching. So at this tree here, you can notice that it's a little bit less than 50% foliage coverage. So this is not a good candidate. I don't believe that this tree would survive treatment and recover. However, on this tree, if you take a look at the whole tree, and the foliage is a little bit more than 50%. So this will be a good candidate for treatment.
Let's do it again. That was good though. You were thinking too much. This is
Yeah.
this is TV. We don't have to think that much.
Uh-huh.
That was good though. Still rolling. Here we go. And anytime, Georgia.
Okay, so can you explain how you would tell which trees are good candidates for treatment and which ones aren't?
When we come into the woods to treat trees, we're going to take a look at the whole tree that we're looking at treating. So we take a look at this tree. This tree is missing more than 50% of its foliage, so it's not a good candidate for treatment. It probably would not survive treatment, or if it did, it's not going to survive more infestation. This tree, however, has more foliage and is a good candidate, so we would treat this one.
Perfect. You want to?
Did you hold it for a while before?
I don't recall.
Okay, it's fine. I'll just cut to something else then. Okay, let's try it one more time.
Give you a short one.
And then what's the other one?
This one, I think I touched it around here. I don't know if you can get foliage.
Okay. Okay, that's where you're gonna be. All right. Take your hand out.
Mm-hmm.
packed in there.
Oh my gosh. Oh man, I hope they. Oh my gosh.
I'd like to have.
How are your parents doing? They've been up to visit Joshua?
Yeah, they
Of
came,
course, yeah.
They noticed when we got out of the hospital.
Oh, did they? Oh, but they are excited.
If you just said that one sentence.
I had no idea how with that
Oh,
kid. I
I'm
mean, it's
sure.
amazing.
One spot is done. I'll start.
We asked, it was funny, we had to go back in that back room or something for a minute, and I was like, Dad, can you watch Joshua? We're back here.
We're rolling. Here we go.
Okay, so can you just describe that little scene over there and what the viewer can see in the trees and on the floor?
So in this area, you can see it's a healthy stand of young hemlocks. And the hemlocks you'll see on the ground are dead trees from hemlock, woolly adelgid, or other disease and fire that are laying on the ground. They're dead. Maybe I can try that again.
They're dead, Jim.
They're dead.
Wait, why? Okay, I know you're only doing this for audio, but why is everything red?
That's the focus. You tell me if I'm in focus.
Oh, nice.
Don't you like red? I mean, I thought they were add a little color to that.
So,
I can turn it off.
Harry, oh, don't turn it off. While we have you,
Yeah.
can you give us a little more description of the pretty part too? We got the dead part on the ground. But
Yeah.
Oh, I see. Okay.
let's hear a little bit about the part that's alive.
So you want me
Yeah.
to ask the whole thing again?
Well, you could just ask. Yeah, you could ask the beginning of it. Like, what are you seeing when you're looking
Don't
out
say
over
so.
this spot here?
Okay. I'm going to say it 50 times now.
Because I wanted to make you conscious.
Yeah.
Sometimes we can eliminate it.
If it's in the beginning, I'm going to say so.
Yeah, sometimes. But if you just go, so we would have. It's
Okay.
no big
All
deal.
right.
All right.
Okay. Can you describe the scene, what you see as you look out over that little place?
What we see here is a healthy hemlock stand. These are mostly young trees, so their diameter is not very big of their tree trunk, but they're healthy. They have green needles, lots of foliage coverage, so that's great. On the floor of the forest, you can see some tree trunks that are laying on the ground. Those are trees that have died from adelgid or other disease or fire. But overall, this is a healthy stand with lots of good-looking trees for the future.
And how about the? Can you describe that big tree that's there at a 45-degree angle? What do you think happened to that tree?
I think the larger tree that's hung up in the other tree probably succumbed to hemlock woolly adelgid. We have a lot of adelgid kill in this area, and so that was probably one of the larger trees that succumbed to the starvation that you see with the adelgid infestation.
Just do it again and just shorten it up a little bit.
Okay. So that larger tree we see hung up, okay. The larger tree we see probably succumbed to the adelgid infestation and died either from disease or some other
Some other nuclear device.
something happened to that tree and it's dead.
But the way you started, we don't need to say about it hung up.
Okay. The larger tree we see probably died from adelgid infestation or some other disease or opportunistic animal infestation. God, you're killing me. Okay, this is it. I'm gonna nail it this time.
Okay.
I'm gonna nail it.
And you don't have to say we see, because we will
Okay.
see it.
And opportunistic is
Too big?
yeah.
Okay. 6th grade. All right. This large tree most likely died due to adelgid infestation through the years.
Good to me.
Why didn't you tell me to say that in the beginning?
Block of stones.
Okay.
Whatever you said.
Anything else? do this please for us? Clap your hands again. Just once. Do it once. Go. Good. Looking right at Georgia. Anytime, Georgia.
Okay, so can I have your name and how to spell it?
My name is Ken Bridle, and that's Kenbridle.
Okay. Alright, so can you talk a little bit about why this water is so good for the hemlocks and like how they interact?
All of the water that's flowing down the falls behind me in this Cascade Creek all comes from within the same watershed of the park. So it's a mostly completely forested watershed. And it's cool water, and the hemlocks and the shade of the hemlocks are what historically would have kept this creek cool. And water that's cool holds more oxygen. You know, when you boil water, you release bubbles. Well, cold water holds a lot of oxygen. So that means a lot of critters that live in the water can live in that water with a lot of oxygen. So that's one of the reasons why you want to keep water cool, is it keeps the oxygen level high and keeps all of the critters that live there, fish and dragonfly larvae and other fly larvae and ladybugs and damselflies and all those things that are all living in there all need oxygen.
And, cut. I'm having a clap. And anytime.
Okay. So can you explain why this water coming out of the waterfall is so good for the hemlocks?
Well, the water is good for the hemlocks, and the hemlock is good for the water. So because the water quality all comes from within the park, it's pretty high quality water. One of the significant natural features of the park are these spray cliffs behind me, which have interesting plants and animals that live there. But the hemlocks historically would hang over the water and shade it. And when the hemlocks shade the water, they keep it cool even in the hottest part of the year, which keeps the water temperature cold enough to have a lot of oxygen in the water. That means that a lot of critters that live in the water can live in that water. As the temperature gets warmer, the oxygen level drops, and then things that are used to high oxygen clear water will no longer be able to live here.
I think that's great. Cut. Take care.
Alright, so what is the hemlock's preferred environment?
Okay, there's two species of hemlocks that grow in this park. We have the Canada hemlock, which is usually down along the creeks here, and it likes moist north-facing or east-facing slopes. It doesn't really like hot summer weather. We're at the southern edge of the eastern Canada hemlocks range here in North Carolina. The other species of hemlock is the Carolina hemlock, and it likes a little drier further up the hill kind of habitat. So of the two species, both are affected by the hemlock woolly adelgid, and the bigger tree, the Canada hemlock, is a big tree, something like 80, 90 feet tall and big around and usually hanging over the creek. And up behind me, the ones you see with no leaves, those are the dead hemlocks. And the Carolina hemlock is a smaller tree, probably in the 20 to 25, 30 foot tall range, and it's further up away from the creeks.
And what hemlock is that?
This is an eastern Carolina hemlock. So this is a baby of the big ones that are up behind me and would historically have lined this entire creek corridor. When you look at the branchlets, the eastern hemlock's needles are kind of flat, and the Carolina hemlock needles stick out at an angle. These are also, if you look closely, they're serrated, and the Carolina hemlock is smooth. And a few other differences that you can pick out.
Since viewers can't see the waterfall, tell us why we're hearing that loud water sound right now.
Well, we're just downhill from the waterfall, so there's a waterfall immediately up to my right, and then there's a waterfall. The next one is down below. I think from the top of the mountain to the Dan River is probably 1,500 feet or something elevation change. So that's all done by rock steps. So there are upper and lower Cascade Falls, there's Tice Falls down below us. So it's kind of like rock fall, pool, and then another rock fall and another pool, and that's kind of how Cascade Creek does until it gets into the Dan River floodplain.
He's really shouting.
Oh, you want them to not
He's
shout
really
so much?
shouting, yeah.
So let me ask you again. Don't shout because
Well,
we're.
let's hang on a second. That's good.
Okay, so just above us is a waterfall. We're sitting in a valley that actually is full of waterfalls. So there's a lots of noise.
Let's just say we're surrounded by waterfalls. We don't.
Okay.
We'll hear the noise. Sorry.
Okay. So the coolness of the water is what makes the habitat nice for the hemlocks. And historically, there had been hemlocks all down this valley hanging over from both sides. Most of the big ones have died off, and if you look up behind me, you can see ones up the hill that are dead. There's a few little ones, like this one at my knee. This is a eastern Canadian hemlock, probably in the neighborhood of 10 years old. They grow very slowly when they're growing out of the rocks. And we're hoping that this is the next generation that'll be filling in after the woolly adelgid allows them to recover.
And tell us about the health of that hemlock.
This hemlock looks pretty good actually, although when I flip over a couple branches, I can see little white spots, which is the overwintering adelgid. The adelgid has two parts to its life cycle. So there's a wingless version that basically infests the trees, and then there'll be another flight winged version in the spring that'll fly away looking for a spruce plant to lay its eggs on, but they don't find that here, so that part dies off. So all the hemlock adelgids that we have are wingless females.
Okay. I think we can talk more about the hemlocks in a quiet and
Okay.
so that's perfect. I'm just curious, did you say you saw some woolly adelgid eggs underneath it?
There are some on here, yeah.
Can you get that? Okay, I think we're done.
They called it the Arts Council. They said, come and get a check. So I've sold 2 paintings so
Awesome.
far in this last I'm 3 months in a row, I think, selling paintings now.
Keep it up. That's awesome.
Yep. There's some Carolina hemlocks up right by the inner. Packed with pockets, it looks like. Or something.
Okay, here we go. Anytime. Just turn your body towards me a little bit as you're looking. There you go.
Never examined one so closely.
And you're by yourself and you're not talking. Thank you. Just keep looking. Thank you. Okay, Emma, do your thing. I shot some stuff rolling. You're just looking around, Ken. Go over to your left. Look at my hand. Now look up. Good. Just keep doing that. You got that sun on you, so go forward, walk forward just a teeny bit. There you go. All the way to your left and up. Stay up and look a little bit towards me. A little bit. Perfect, perfect. Back over to your right. Okay. Are you good, Emma?
I'm good.
We're both rolling. And if you'll do the clap, please. Talking to Georgia.
Okay, so can you tell me your name and a little bit about what you like to do in your free time?
I'm Ken Bridle. I'm a full-time tree hugger, so mostly when I'm not out in the woods doing biological inventories, I'm at home gardening and making applesauce, and this time of year picking grapes and things. I also like to bicycle, a little bit of off-road bicycling. One of the things I found out in doing inventories is usually you park your car someplace and then you hike a long ways away and then you have to go back to your car. So now what I do is I leave the bike somewhere, drive to some other end of the valley, drop off the car, hike down to the bike, and then bike back to the car. So that's kind of killing hobby and work at the same time.
Just hang on one second. Just keep rolling.
I should say free time. Who has free time? I also watercolor paint.
All
So-
right. We are still rolling, so anytime, Georgia.
Okay. So you mentioned that you have a garden. Can you tell me if you have any hemlocks on your property?
I do. I have two. Moved them from some family land up in Nashville. So I have two Canada hemlocks that started out as little things that fit in my pocket and now are a good 4 or 5 inches in diameter, and so they're growing nicely.
So what's happening in this area with climate change, and how have you maybe seen that in your own garden?
Climate change is causing the weather to be weirder, not as reliable. So in my garden, I've seen late frosts that have killed off the blueberry blossoms and no blueberries. It's also warmer in the wintertime, so the apple trees don't go fully dormant, which means they don't make buds like they should in the spring. So apples are really a cool weather crop. So we're right on the southern edge of that. I see my honeybees come out in the middle of winter and start flying around looking for flowers, and there aren't any. So that's one of the reasons we have honeybee problems, is they use up their resources looking for flowers in January on a 60-degree day, and there's nothing for them to find. So things like that.
So do you have another name for climate change? I think I might have heard that.
I call it global weirding, because really it's more than just, it used to be global warming, but it turns out climate change is better because some places are going to be warmer, some are going to be drier, and ours is just not as predictable. I mean, we have more storms, we have hurricanes out of hurricane season, we have thunderstorms in the winter time, so things are happening that are just not as reliable. And you know, if I was a full-time farmer, that's even more of a problem.
How is climate change affecting the hemlocks in the park specifically?
We're on the southern edge of the Hemlocks territory, the eastern Hemlocks territory. So it's when it gets hotter than it has been or drier, we have droughts and high temperatures, and you can tell with all the rocks around here, we have pretty shallow soils up here in the park. So it makes them more susceptible to the woolly adelgids when they're stressed. So almost any plant that gets stressed either by drought or storms or temperature or something, then that stress makes them more vulnerable to other pests, which is one of the things we see that's happening here in the park and other places nearby where hemlocks occur.
So I know that there's only a couple of distinct places that you can find hemlocks. So can you talk a little bit about the growing zones that they grow in and how that relates to climate change?
Sure. Since we're on the southern edge of their habitat, they prefer to be in places, especially the Canada hemlock, that's more like Canada. And that means the north sides of hills, which are usually the moist and cool side. So the north side of a stream bank down in the Piedmont. There's one location where hemlocks are in the Cary Triangle area at Hemlock Bluffs, and if you go there, they're on a north and east facing bank where they don't get much hot summer sun. So all the places that I know of in the Piedmont where hemlocks occur, they're either on a north facing slope or an east facing slope where they spend most of their day in the shade.
Why is this area unique for hemlocks? I know you talked a little bit about they want an environment like Canada, but why is it so unique that they're here in North Carolina?
Well, we're at the southern edge of their habitat. So 15,000 years ago, when glaciers moved everything south, we had a lot of Canadian flora and fauna here. And when the glaciers moved back up and went away, a lot of places like the top of this mountain, there's vegetation stranded here that would be from up north. So we have, this park is a good example of, there's northern things here that we're the southern edge of, and we're also the northern edge of a lot of southern things right up by the Blue Ridge. So the biodiversity in this part of North Carolina is pretty high because we're on the northern edge of the Piedmont and we're on the southern edge of the mountains.
Okay, so would you mind going into a little bit of like exactly the kind of similarities you see with Hanging Rock and your own garden? I know they're in the same area, but what are some specifics?
I'm probably only 2 miles, or no, about 6 miles away from here in my garden, but I'm about 1,500 feet lower. So every 500 feet that you climb in elevation, it's equivalent to driving 400 miles north. So the weather on the top of Hanging Rock is always 10 or 15 degrees cooler than it is down in my garden. And in the wintertime, when the leaves are off, I can see Hanging Rock from my yard, and frequently I see a crust of snow or ice on the top of this mountain, and it's shirt sleeve weather down where I live. And then alternatively in the summertime, one of the reasons this park is so popular is when it's 95 degrees down on the Piedmont, it might only be 85 degrees up here, and it's a lot cooler. So the elevation allows you to be a lot cooler and breezier up here.
So, can you talk a little bit about the history of Hanging Rock and as it relates to hemlocks? Like just anything that might have happened to them in the past?
Well, hemlocks are not a really sought after timber. The wood is not good for construction purposes. So the hemlock trees and the chestnut oaks, which is a kind of oak that occurs around here, those are really gnarly and aren't also well sought after by loggers. So in the early 1930s, almost all this park was timbered, clear cut. And then they left the big trees down in the valleys. The hemlocks are older than that. It's because they weren't valuable. So the park was pretty well timbered over, and then all of what you see has regrown since about 1935 or thereabouts. That's when the CCC started built the park. So now that there's no forestry involved, the trees and everything are maturing, but most of the southeast has been cut over probably 3 times since the colonial period. And every time you cut a forest, you lose about 15% of the species that were living there before. So you never really get 100% back. And if you've cut 3 or more times, you might only be looking at 60% of the diversity that was there originally. So one of the reasons we like having parks have management that actually helps remove invasive species, bringing prescribed fire back, because that's an important part of the landscape maintenance. So they're doing things which are helping to improve the park and restore a lot of that biodiversity.
So kind of on that same topic of biodiversity, do you happen to know how much of Hanging Rock is made up of hemlocks, like roughly?
Probably of the several thousand acres, there might be maybe 100 acres of hemlocks, but they're not ever like the ones we saw in the valley, except for the creek corridors. There's a hemlock here and there, but they're not grouped together. So it's not like you can draw a line around it and say, but there's probably 100 acres, so maybe a couple percentage of the park would be hemlocks.
And why are hemlocks so important to the area?
Well, mainly because they're a important canopy tree and an important evergreen. And most of what we're looking at here is deciduous stuff, and you want to have evergreens in the wintertime. That's where birds take shelter during storms, and that's a nice nesting habitat. And hemlocks there are migratory birds that like hemlocks and pines. So we see the warblers that come through. You can find them in the hemlocks because they like evergreens. And eventually they're heading north. They're going to be nesting in hemlock forests, probably up in Canada. So it's just it's an important part of the biodiversity of the park.
And kind of,
Just keep rolling.
good ears.
I'll tell you what, let's cut. Is this, if you would do, you rolling, Emma?
Yeah.
Clap, please. Good. All right, Georgia.
Okay, so what does this area, Hanging Rock, this part of the state, mean to you?
Oh, this is home. I've lived here. My wife and I have been in this neighborhood for about 38 years now, something like that. And even before then, when we were graduate students, this is where we would come to play when we were graduate students. So I've probably been coming up to Hanging Rock for like 45 years. My wife has been on the park advisory board for probably 25 years. I've worked to help build exhibits for the park, and I've narrated some park videos and helped build trails. And after a hurricane one time, I took a chainsaw safety class and helped clear the trees from the, whatever that was, March '86 hurricane that we had. So we come up here a lot. We don't come up here on weekends, and definitely don't come up here on holidays, but middle of the week, that's when all the locals come up here. So we like it here. I mean, we also like it as a field biologist. I like it because I can always tell where I am in the county by seeing where Hanging Rock is on the landscape. So I know it's just like Pilot Mountain is a very important knob that people say colonials navigated by and Indians navigated by it. So when you get a distinct feature on your landscape, it really makes it look special. So
Slide forward just a little bit, please.
So you study plants, you love plants, obviously. When did that relationship, affinity for plants start, and how did it start?
My father was a very avid gardener, and his mother was a very avid gardener, and I learned details like how to build a compost pile when I was probably before I was even a teenager, and I was a gardener before I was even a teenager. And my father used to take us on hikes when we were little tiny kids. So I've been out in the woods since I was 4 or 5 probably, and then I grew up in the generation of children whose parents said, get out of the house and don't come back till dinner. And I would be out unsupervised with friends playing in the woods all day long. And so I just grew up out in the woods all the time and turned into a plant physiologist by training. And I've had, my career spans from plants growing in Skylab in space to one of the first transgenic plants experiments in North Carolina, and then ultimately to biological inventory and biodiversity studies. So I'm getting more conservation minded as I get older.
up, I just want to know if you could sum up the importance of hemlocks in the park and what people should know about them in general, and to just like a little blurb, what would you say to people?
I would say people have to be very conscious of what they do to the environment, because we know the adelgid was introduced into Richmond, Virginia in 1951, probably in nursery stock. And every year we have new critters to contend with. We're in an area now where gypsy moths are coming. We've got fire ants on the landscape. We've got things that people move around in firewood, like emerald ash borers, which eat your ash trees. So a lot of things are happening in our environment, and a lot of that is because of what people are doing, moving things around. As a conservationist, I don't believe anybody wakes up in the morning wanting to destroy the environment. But we all do by our unconscious interactions with the environment, and our kind of mindless interactions. And I think more people need to be mindful of what they're doing, and that would help Mother Nature out a lot.
So, do you have anything else to add? Maybe anything that I didn't ask you about that you wanted to talk about?
No, I'm good. I'm good. I'm glad you're doing this project. It's good to highlight the park, and good to highlight the problems that the adelgid and other problems that the park species have. The park staff can use all the help they can get to make the public aware, especially since this COVID thing. There are people using the parks now who have never been out in parks, and I don't think they have the ethic to know to just take photographs and leave footprints. So there's been a lot more trash, a lot more impact on trails. You know, it's just being loved to death, and I think we all have to be conscious of our part in that.
Is there anything about, as someone who is very close to nature, personally and professionally, is there anything that like gives you hope in the midst of climate weirding or humans' impact on the environment at this point in time?
There are lots of things. For example, when the economy shuts down for whatever reason.
If you're going to answer, go
Sorry,
ahead.
do you
Okay.
mind talking to Georgia?
When you come on slide 4, the sun is really killing this guy, so we got to
Okay.
figure it out here, or change angles or something.
Okay. So
Hang on 1 second, please.
Okay.
Sorry. All right, Georgia.
I think that a lot of climate change and a lot of impact on the environment is done by people who are unconsciously doing things, and if it doesn't take much for us to get conscious about things and make changes. So whenever the economy shuts down, like during COVID, then all of a sudden we saw the planet's air clear up. People in India saw the Himalayas that have never seen the Himalayas from where they live. People around here, you know, we noticed the air was clearer. We noticed, you know, with a small amount of stream restoration, we can clear up a creek channel. You know, if we put buffers on our streams and creeks, then our water quality is better. So there are things we know how to do, and the more people pay attention, the more those things get done. So, I mean, it's just very simple. People just need to pay attention to, you know, what they throw away, what they purchase, how they spend their money. It's easy.
Okay, are we good?
Great.
Okay, cut. All right, come by. Net sound.
Now, how much you'll put in the way of the tripod too? I'll do that.
Well, that's okay. All right, here we go again. I give up.
Yeah.
Okay,
Does he know to walk by the camera?
just walk by the camera.
So again, let's get off the scale, because we
Good. Okay. Okay. Okay, just walk by me. Very nice.
I'm shooting. Okay.
Okay.
This is a loud leaf blower.
Good. Okay.
For you, Bob.
Just take one step back
Not gonna work.
and go.
Oh, landed.
Almost made it. All right. Come down with, just back up one step. And come down with your left, back your left foot up. There we go. And put your left foot first and then the other. Go. Give me one more. Go. Okay, give me one and have your left foot go solid on the ground if you can. Go. Okay. What you're doing is if you could hit that area, it would be great. All right, take it away and go. And just leave it there. Good.
It's a little wobbly.
Okay, give me another one. Go. And, hang on. One more. Good. And look to your right. Yeah, just straight ahead. Look to your left. All the way to your right. Even further to the right. Good. And straight ahead. Good.
I can call them in, they'll kill one of this and two of that and all that stuff. They were shooting and all that other stuff. And that's okay. This doctor friend of mine used to go down the beach, and that's back when you could kill a swan, they could kill snooki. The guy killed a swan, he thought he killed
Okay, be looking it over. Just keep looking.
Just keep
Thank
looking.
you. Yeah, you're doing great.
Just keep looking.
Not your head down, not quite that much.
Okay.
There you go. What you're doing is perfect, Jim.
well?
I can hear you very well.
Okay.
All right, go ahead.
All right. So, how much of Hanging Rock would you say is hemlocks?
Hemlocks are scattered throughout the park. There's probably 100 acres or so if you concentrated them together, but they're not a dominant tree, but they're very important because they're one of the few evergreens. So they're important for a lot of reasons, but
Start again.
How much of Hanging Rock would you say is hemlocks?
they're the dominant species along creek banks, but then they're scattered throughout the park.
Let me just ask, try not to use the pronoun they, because people won't know what it is.
Okay.
So I just repeat
Okay.
them like
Okay.
that.
Okay. Hemlock trees are
Ask one more time.
okay.
Sorry. That's the wind.
Days.
There you go.
Tropical storm anyway.
Once more with feeling, please.
How much of Hanging Rock is hemlocks?
Hemlocks are an important component of the forest along creek corridors, but then they're scattered throughout the rest of the park. Two different kinds of hemlocks. They probably don't take up more than 100 acres or two of the park, but they're an important species of tree because they're evergreen, and there's only a handful of evergreens in the park. And there are species that prefer other species of insects and birds that prefer hemlocks, so they're a necessary component of the biodiversity.
And so, what would the impact be of hemlocks disappearing from Hanging Rock?
We really don't know if hemlocks disappeared what would be the total problem. We know the creeks would get warmer because they're not shaded by hemlocks anymore. We know some insects would lose their host plants. We know some birds would lose their nesting sites. But really it's hard to tell. It's kind of like if you took the clarinet section out of an orchestra, what would an orchestra be like? Or, if you got rid of timpanis in the orchestra, what would it, so we're really not sure, but it's a loss of something significant. I often think of the game Jenga, where you pull little wood blocks out until you pulled out so many the whole tower collapses. So it's something like that. Probably you can't lose too many species in an ecosystem before you start to lose a lot of important ecosystem services.
Great.
They good?
All right.
That's it.
Thank you.
Good job. to your right a little bit. Just look to your right a little bit. Go. Back to your left. Just make sure you don't hit the camera. Look at the camera. There we go. To your right. Left. To your right. Good. Here we go.